In your notebooks, go ahead and write down the law of sines. Now there are three fractions that all equal each other. We are just going to use two of them at a time to solve a proportion. Okay? So depending on the information we have, we might need the A's and B's, and we'd use those two to solve. Or maybe we need the A's and C's, and we'd use those two and solve a proportion. Okay? You're not going to use all three of them equal to each other at once. We're just going to grab two at a time for what we need. Okay? Now, there's only specific times where we can actually use the law of sines. Okay? First of all, we need an oblique triangle. If it's right, we're going to use Socotillo, right? Second of all, we need three specific parts of the triangle. Okay? Now, don't panic when you see three letters and some of them are A's and some of them are S's. We are not doing any geometry proofs. Okay? What we need, and this is what we're going to focus on today, and we're going to leave this for tomorrow. But if we have two angles in a side, whether that side is included or not included, we can use the law of sines. And we can use the law of sines when we have two sides and an angle not included. These are the three cases we're going to use the law of sines for. Now, if I were you, I would just write down these three-letter abbreviations. Okay, those are going to be important. You don't necessarily need the description. Okay, but these are the three cases where we can use the law of sines. So when we are given information, we'll draw our triangle, where we will evaluate what sides, what angles do we have. If we have any of these combinations, we can use the law of sines to solve for the rest of the angles and the sides. Okay. Now, if you are done writing it down, you'll want to get your calculator out. And everybody needs to make sure they are in degree mode. So today, in our example and in your homework, you are going to get either angle, angle, side, or angle, side, angle pieces of information. Tomorrow we're going to focus on side, side, angle. We call that the ambiguous case, and there's some crazy things that can happen there. Okay? So we'll focus on that tomorrow, and we'll stick with just these two here today. Okay? No matter what, I want you to draw a picture. It does not have to be drawn to scale. Just draw a triangle, fill in letters and numbers, and so that you can visualize what's happening. Okay? You're not going to draw it to scale. Don't even try. Right? So, this is the information that we have for triangle ABC. We know angle A is 32 degrees, angle B is 50 degrees, and then C is 18.7 centimeters. You may have picked up on this already, but capital letters are going to stand for angles, and lowercase letters are going to be the sides. Draw a triangle. I don't care what it looks like. My triangles all look the same, even though they're all different. Okay? We know that angle A is 32 degrees. We know that angle B is 50 degrees. And side C is 18.7 centimeters. Okay? I want you to notice that we have an angle, a side, and an angle. The side is in between the angles, so we call this angle, side, angle. With this given information, can we use the law of sines? Yes, we can. All right, fabulous. What is the first thing, the easiest thing to find?
Angle C.
Angle C. We have two angles, we need the third. Okay, so angle C, how are we going to find it?
180 minus
180 minus the other two angles. All right, what do we get? 98 degrees. Okay, so angle C is 98 degrees. You may not know this, but when I was growing up, 98 degrees was a band. But you would not know that because
Where they do it?
they're like a boy band. Like, so Jessica Simpson used to be married to Nick Lachey. Do you know Jessica Simpson anymore? Okay. He was like basically the band. Anyway. Long time ago. Long time. All right. So now we have that angle. Okay. Keep in mind that sides are going to be across from their respective angles. So since this is angle A, across from it is side A. This is angle B, across from it is side B. Okay, so now we can decide which side we want to start with. Anybody have a preference? A, we like to go in order. Okay, so we are going to use the law of sines. We know that the sine of, we're using A, right? 32 degrees over side A. So sine of A over side A equals, should we use the pair of B's or the pair of C's? C's. The pair of C's, we actually have both of them, so that's the only ratio that's going to help us. The sine of angle C divided by side C. Okay? Now we have a proportion to solve. How do we like to solve proportions? Cross multiply. So we know 18 times the sine of 18.7. Oops, sorry. 18.7 times the sine of 32 degrees should equal A times the sine of 98 degrees. Okay. With your calculators, I meant to pull up my calculator. So in your calculators, you can put this in all at once, or, oh, come on. There we go. You can put in 18.7 times the sine of 32. If you're going to put it in all at once, you have to remember to close the parentheses after you put the angle in for sine. And then you could divide by the sine of 98. Okay, so we end up getting 10.01 centimeters for side A. It's going to have the same label as the other side. Right. So now we have all of the angles. We have two sides. We have side B left to find. Okay, so we're going to use our proportions again. But this time we need the sine of angle B over side B. Now, B is our last side left to find. Before you get ahead of me, please listen carefully. The more given information you can use, the more accurate your answers are going to be. This is a rounded answer, do you agree? Okay, so if we use this, then we're taking a rounded answer and then we're rounding that answer, okay? My preference is for you to use as much given information as possible. So since we already have the pair of C's, okay, and those aren't rounded answers, let's go ahead and use those to calculate for this proportion. Okay, so same kind of work here, cross multiply. 18.7 times the sine of 50 degrees is going to equal b times the sine of 98 degrees. What do you get for side B? 14.47 centimeters. Anytime you go through a problem, you need to go back and look at your triangle. Do our answers make sense? I see that our biggest angle is across from our biggest side, and our smallest angle is across from our smallest side. Those things should happen. Okay? So does our answer make sense? Does our triangle make sense? It does. Okay? The triangles you will solve in tonight's homework will either be angle side angle like this or angle angle side. It's not going to affect the order in which we do things. You're still going to find that third angle and then get the other two sides. Okay? Just make sure you use as much given information as possible. Okay? Now, we also have some formulas we can use to help us find area. Okay? How do we typically find the area of a triangle? 1/2 base times height. Nice formula, right? What's not nice about that is if we don't know the height of our triangle. And sometimes that can be complicated to find, right? If we don't have the height, then we have to draw it in a right angle and try to figure out what that height actually is. And sometimes we don't have enough information to do that, okay? The law of sines is this formula here. But we also have an area formula that we can use, okay? Now, there's 3 formulas here. You can write one of them down and be fine, okay? So what you need is to write at least one of these formulas down, and that we can only use it when we know side angle side. You'll notice in each of the formulas that there's an A, a B, and a C, okay? So if you write down one, you can adjust it depending on what triangle you have, okay? This only works if we have 2 sides with the angle in between. It's basically a shortcut for us not to have to find the height of the triangle for 1/2 base times height. I can't say for certain, but it's possible there is a proof for this in our book, if that's something that interests you, probably at the end of chapter 6. Okay. So we're going to do one example of us finding area. Here's our given information. Angle C is 102 degrees, side B is 52 meters, and side A is 90 meters. I know that my triangle is not drawn to scale, and I really don't care if our triangles are drawn to scale. We more need a visual of where the angles and where the sides are. Since we have an angle in between two sides, that's how we describe side, angle, side, the angles in between the two sides, we can use our area formula. And our area formula is 1/2 times the two sides times the sine of the angle in between those two sides. Anyone have an answer for me?
I got 2,288.7 square meters.
Ooh, and I like that you included those square meters. Okay? If there is a label, I expect you to include it. Okay? Also, I want to be clear that my expectation is that we round to 2 decimal places. Okay? Round to 2 decimal places if you need to round. All right, so we're kind of easing, excuse me, we're kind of easing in to this chapter, okay? I'm going to hand out your gold sheets. You will see the schedule, and I want to kind of talk about the schedule here. Okay, so you can see that we're going to go through the ambiguous case tomorrow. We're going to look at that third case for law of sines. Monday, we're going to talk about law of cosines. We'll review, then a quiz, and then we get to do, first of all, a Star Wars activity, and second, a project before we continue on. Okay? What I'd like to have happen in the last 7 minutes of class is for you to get at least one book open on your table and complete at least one problem on your homework before you leave. 4 people can share a book if it's just one problem.